What if we fix the mean value? Before, without fixing the mean, we have this kind of a distribution graph, right? So the graph is moving a little bit toward the right side, and the more data is in the very small range here. But now, next topic, we want to fix the mean, which means, let's say we have such kind of some kind of real data set like this, and then now the center, this data also have mean value exist here. Okay, now we fix this mean value and then find maybe sample distribution. Then if n equals 2, then only 4 cases here, right? So in this case very lower, and then just become somehow like this. Because only 4 cases exist when n equals 2. We just review from here, but I'm not gonna actually bring out such data, so we can play out with the fix the mean value, because it will be much complicated anyway. Now if n equals 3, so this is the 2 case, n equals 3, then it get taller. So far it come like this, and then going toward up a little bit and passing here, then something like this. Okay, so that's the n equals 2, and then this become n equals 3 here. Now n equals 4, then distribution is suddenly taller and then skinnier, so it's getting taller and become like this. That's n equals 4. Now n equals 5, they're even taller than this one, so if something like this. And n equals 6. So come to a little higher, and then somewhere like this. I cannot even fit in this kind of cases here. So the gray one is n equal to 6, and blue one is n equal to 5 here. Okay, so like when you do a sampling mean distribution, the graph shape becomes normal. Okay, so then what does that mean? So now whenever we increase number of n, then it is concentrated on the mean value, which is center more and more, and then there are more repeating data. It is gathering to the center basically. Okay, that's why the distribution is skinnier and then taller and taller. So as you see previous data, when n equal to 3, we have already 27 total sample size, and then n equal to 4, 256, n equal 5, 3125, n equal 6, 46,650 56 data cases. But we usually say big normal cases n equal 30 here, then gets 30 to 30 power. This is such huge data, and then it got much taller and skinnier basically. So now I'm gonna just maybe choose one normal, just normal popular normal cases, and then one sampling cases, and then merge together here. So let's say we have one normal graph like this. So this is our population normal graph. Now if we do sampling distribution for this data, then it will be towards center more, and then it got much taller, something like that, right? Okay, now when we look at the original data, so which I'm gonna keep on indicating green color here, then around this is sigma 1, first sigma, and then around this is second sigma here, right? and this is -1 sigma, and there will be -2 sigma like that. But now when you look at the red distribution, this doesn't reflect actually red distribution graph, because the red case I can conjecture sigma 1, which is one turning point, is around here, then right here, and second one exists around here basically. Okay, so yeah, I'm not good at drawing this case, but so which means, you know, original sigma, which means standard deviation or the standard error, doesn't reflect sample distribution sigma value anymore. Therefore, you know, when you do sampling distribution, the sigma value must be adjusted. Otherwise, we cannot find the probability value, because population data and then sampling data, they are totally different distribution, even though they are from the same data set. Good? Therefore, we do sampling mean, usually indicate mu x bar equal to mu basically. But sigma x bar must be adjusted. So that is the formula. Look at here please. This is original sigma over root n. So when you look at just conjecture here, if n is bigger and bigger, then sigma divided by bigger number, which means whole fraction value will be smaller and smaller. That's how we conjecture the sampling distribution case. If number of sample increased, then sigma value will be decreased. Okay? Then from next video, we actually solve for some example problems.